Thanks.
खुद को खोकर ही खुद को पाएगा, रुकना काम नहीं तेरा आगे बढ़ता जाएगा। मुश्किलें जितनी आए हिम्मत नहीं हारेगा तू, याद रख तू कौन है, पर्वत को चीर फाड़ेगा तू। पंख नहीं दिखते तेरे पर भर ले तू ऐसी उड़ान, उड़ जा नन्हे पंछी कर दे सब परिंदों को तू हैरान। कोशिशों से मिलती कामयाबी, कामयाबी का तू हकदार है। रास्तों की खाके ठोकरें, जीतने के लिए तू अब तैयार है। ओ रुकना कैसा, डरना कैसा, बात नहीं कोई अब डरने की, कर ले जिद आगे बढ़ने की। बात नहीं कोई अब डरने की, कर ले जिद आगे बढ़ने की।
Good evening, everyone. I'm your host Manpreet. Welcome to the fourth season of IST Practicals by Internshala Trainings. IST Practicals is a series of free online masterclasses delivered by industry experts. These 45-minute sessions are all about teaching students important concepts, softwares, and tools. Every IST Practical is an opportunity to experience the power of practical learning. The topic of this session is Revit, and our teacher today is Mr. Stephen Fagan. Steve has a Bachelor of Science in Architectural Technology and 10 years of practical experience working for an award winning residential development company in London, as well as his own company, S15 Studio. He undertook all project related design and management tasks, requiring him to design, draw, and coordinate multiple high rise residential buildings from the beginning of every project, no matter what the scale or scope of this project was. All design tasks were developed using AutoCAD and Revit, which Steve has been using for over 15 years. He has been certified by Autodesk as a professional under the ACP, and he is also a certified trainer under the ATP. Steve has extensive experience as a trainer, teaching small and large groups, both in situ, in a classroom, and online digitally. He has been retained to train primarily in the UK, but has had opportunities to teach in a number of European countries. I hope you will enjoy this webinar with him. We are giving away special rewards to one selected person today, so don't forget to participate in all the polls and quizzes. Do mention your email address whenever you answer a question that is asked by Steve. This will help us in reaching out to the winner. And without further ado, let's welcome Steve.
Hello, and thank you, Manpreet, for the introduction, and hello to everyone watching today. First, I want to get to know everyone a little bit better and understand what kind of experience you have. So I'd like you to write in the comment section, please, if you've had any experience with Revit before. Like, have you ever come across it? Are you using it in your current role? So if you'd like to add into the comment section so we can see how we're all doing today. Yeah, so have you had any Revit experience in the past? Yeah. That's great. No, that's no problem if you don't have any experience. So I'm going to take you from the very basics just to give you a good idea of the software today. So yes, some no. That's a good mixture. So are you currently working in the construction industry yourself? Do you have any experience at all within the development of buildings, the designing of buildings? Yeah, brilliant. Yeah, and don't forget to add in your email address as well. Do you also have any experience using AutoCAD? Have you come from the 2D design side and you're now looking to go into the 3D design? No experience. Yeah, some experience. So it's pretty broad. It's great to see. Okay, so all great answers. So the aim of this webinar is to give you an insight into what is Revit. So how can it benefit you, and also how it can help you on your career path to using Revit. So what I'll do is I'll begin with some quick theory on Revit and BIM as well. There will be some questions for you to answer as we go along, and I will also do a quick demonstration, a quick project at the end, so I can demonstrate those capabilities to you. So we'll start off with, what is Revit? So Revit is a software widely used for the modeling and documentation of construction projects. Today, it is a prerequisite for any professional who wishes to use to work in architecture, engineering, or interior design. Aligned with BIM, the BIM concept, which is building information modeling, which is something we're going to cover in a few moments. So with this, it's a fully parameterized resources. So Revit offers agility, precision, and organization to your project in a way that other CAD softwares cannot provide. So with that, what we'll do is we'll do a small demonstration or comparison between Revit and AutoCAD. So AutoCAD, yes, it is an excellent software if you want to create simple graphic representations. For example, to represent a 20 centimeter thick wall, we just draw two parallel lines spaced 20 centimeters apart. However, if you ask AutoCAD about what it is on the screen, the answer would be two parallel lines. With Revit, we have a tool to create walls, offering us the ability to configure the number of layers, type of material, function, thickness, and various other information. In addition, it allows us to extract this information, this very important information, and add it into tables and schedules. While AutoCAD is a CAD software, meaning computer-aided design, Revit is a BIM software. So this is geared more towards construction, allowing, in addition to an accurate 3D simulation of the work and the coordination of different design disciplines. So who uses Revit? It's generally used by architects, structural engineers, mechanical, electrical, and plumbing engineers, designers, and contractors. To truly benefit from the software and to understand its functionalities, a good basis of construction knowledge is necessary. So what are the advantages of Revit? So within the construction market undergoes constant updates, which implies more complex projects, making any project increasingly challenging. So Revit reflects this scenario. Being a robust and multifunctional software, it offers a range of features that we do not find in traditionally used softwares like AutoCAD. So here's an overview of some of the benefits of Revit. First, we have parametric modeling. Parametric modeling is an all-inclusive phrase referencing the creation of 3D models from a set of rules. Revit uses parametric modeling via what are called families. Everything in Revit, from title blocks to 3D views to building components such as walls or floors is part of a family. Some are built into the software, some accessible through libraries, and others are built from scratch. So this gives Revit models greater control over building design. So automation. So all information that is used to create a Revit model is housed in a single database. This means that whenever you make a change in the model, the database gets updated. The changes are carried throughout the entire model, enabling automation and making the building design process more efficient, and also eliminating some of the rework that comes with chasing changes around our various project files. We'll move on to collaboration. One of the more distinct differences between Revit and AutoCAD is the ability to allow multiple users to work in the same Revit model at the same time. So where one user can make changes to a DWG file at a time within AutoCAD, within Revit, we can have multiple users work on the same file. So by using the Sync with Central tool in Revit, users can push their model changes to a central model while also pulling any changes from that same central model made by your colleagues into their local copy of the model. So a good, powerful advantage next is scheduling. So in the same vein as a Revit model functioning as a single database of all information in the model, scheduling in Revit cuts down on the time traditional workflows demand. As changes are made in the Revit model, schedules that have been set up will instantly update as well with those changes, streamlining one of the more time-consuming processes in the architectural design process. Next, we have energy analysis. So sustainability is a hot topic at the moment. So sustainable design is crucial in the design and construction processes these days. And Revit features several analytical tools that can help measure the environmental impacts of your building design. We then have rendering presentation, the ability to create 3D drawings and renderings directly in Revit rather than import your model into a different software like 3D Studio Max saves quite a bit of time. So Revit provides tools for 2D presentations and 3D visualizations delivered using Revit's extensive material library and rendering plugins. And lastly, we have drawing sheet setup. Because all information is intelligently connected in Revit, changes made in one view are carried through to another. For example, if I move a wall in a floor plan, that will automatically be updated in other plans, sections, perspectives, etc. When views are dropped onto a sheet, users can be assured that changes no longer need to be chased around an entire drawing set housed within multiple files. Instead, the user makes a change in one view and can confidently print the drawing set right away, knowing that the waterfall of changes tied to that one edit will automatically be carried through the entire drawing. So we're now going to move on to a couple of quick questions. So what I'd like you to do is to answer that in the comment section by writing A, B, C, or D. So our first question, AutoCAD is a CAD software. What kind of software is Revit? Is it A CAD software, B, data software, C, BIM software, or D, CAM software? So just write in the comment section A, B, C, or D. That's great. So we're all getting the correct answer. So of course it is C, which is BIM software, again, meaning building information modeling. Our next question: what are the two advantages of using Revit? So we have two options here. So you need to mark in two options. First, we have collaboration. B is improved product photos. C is scheduling. And D is retouch photography. So here we have two answers within this set. So what are the two advantages of using Revit? Selecting two options. A, collaboration. B, improved product photos. C, scheduling. Or D, retouch photography. That's great. And don't forget to write in your email address as well to be eligible for the course. Okay, so we see it. All the answers seem to be correct. A and C is the answer. So collaboration and scheduling. So well done, everybody. So next we'll move on to BIM. So what is BIM? So the Autodesk definition of BIM. So building information modeling is the holistic process of creating and managing information for a built asset based on an intelligent model and enabled by a cloud platform. BIM integrates structured, multidisciplinary data to produce a digital representation of an asset across its lifecycle, from planning and design to construction and operations. So next we have the life cycle of BIM. So when we apply BIM to a building, we want to generate the path for that building. So down in the bottom left-hand corner, I have the demolition, which is the first or the last stage of the building's life. So first we determine, do we want to demolish the building or not? So if we demolish the building, the next stage then is to develop a new building from within that site. If we do not demolish the building, we move on to the next stage, which is renovation. So we'll renovate the building. From that, once that has been determined, we move on to the programming. So the programming is basically creating the scope of work for this project. So do we want it to be residential, commercial, how many flats, office spaces, what size, does it have a basement, car park, this kind of idea. So we need to create a program. How long do we have as well? Do we have 6 months, 5 years? All of this is created at this stage. Next, we move up to the conceptual design. So here, this is down to the architects and master plan architects. What they'll do is essentially like a blocking exercise. So there's no need to fully design the building at this stage. What we'll do is we'll take masses, like just rectangles, squares, this kind of thing, and we'll create a blocking exercise to create a visualization of what kind of concept we want to come across. So we don't want to spend all of our time fully detailing and choosing what walls or windows at this stage. That's the next stage. So this is the concept design stage. Once that has all been agreed upon, it then moves on to the detail design. So all of this can be undertaken in Revit. You can, from the concept design and the detail design, right around from the analysis documentation as well. So all of these processes can be done within Revit. So the detail design is when we have agreed on the concept, we can then fully develop our wall types, the footprint of the building, the floors, how everything joins together, and so on. And once that has been built, it then moves on to the analysis stage. So we're able to see how well the walls perform, The glazing as well. Is it letting in too much light? Is there too much sun coming in, heating the building? Does the building overshadow buildings around it? All of these types of analysis can be undertaken. And then once all that has been finalized, you then move on to the documentation side of it. So this is our floor plans, our scheduling, our details. All of this is gathered together under what is called our buildings documentation. So then this allows the buyers and so on to send it out for fabrication and costing. They understand what needs to go into the building, so they have a better idea of price. Next stage is the fabrication. So actually creating the components for the building, like a simple thing like a door and a window. Those things need to be developed and built for the building so it can all be put together. So is it steelwork, concrete? All of those things need to be fabricated. Next stage is the construction. So this is called 4D or 5D. Within the BIM environment, they have what are called BIM dimensions. And if you've been using AutoCAD, you have essentially been creating what's called BIM 2D. So it's the second dimension of BIM, and Revit is the third dimension of BIM. So when we push it forward, 4D is our cost and 5D is the time. So by using BIM with Revit, we're able to determine the actual cost of the building, and we're able to determine how long it'll take to build. So it's extremely powerful. Before, this would have to be sent off for quantity surveyors and all of these to gather all this information together to get a rough idea of how things will cost. Now we can do that all within one software, and we have a better idea of this. Next is the construction logistics. Basically, this is when do we need a crane to come on site? When can we start digging the foundations? When does the concrete need to arrive? This kind of logistics needs to then be created. And then the building itself is built. So once a building has been built, that's not the end of the building process. It has its life cycle. So the building could be there for 100+ years. So it needs to be operated and maintained, which is the last stage essentially of the building. So we need to understand how the building operates. So for the new owner or the new owner within 10 or 20 years, they need to understand how the water system operates, how the heating system operates, how the building needs to continue to operate. As well, we can add in maintenance schedules. So when do the windows need to be cleaned? When do the filters in the water system need to be changed? When does the roof need to be changed? All of this is added in to the operation and maintenance documents. And you can also create the final demolition stage as well. That's also part of the BIM process. So BIM reduces surprises in the building process and can reduce overall cost in the construction projects. So a coordinated database lets owners, project managers, estimators, and other stakeholders to make data-driven decisions before and after the building is complete. It can help with estimating, budgeting, and operations management for the building's life cycle. So as well as the BIM for the modeling, we also have what are called building information modeling objects, or BIM objects. So these are the components of the building. So BIM objects are the components that contribute to the model, for example, a door. So when elements are changed, the software will update the model to reflect the change throughout. So this keeps everything coordinated through the process and shows how it will impact cost, timelines, and other resulting changes. So BIM within the future. So how is BIM going to change or is changing the construction industry? So in the future, there will be a golden thread of information that is collaboratively developed in parallel to the design and construction of built assets. So this will be a record of what has been built, what is being developed, and developing a record of how the asset is performing. So this will in time be the big data that helps decision makers continuously improve a build to build a safer and more sustainable built environment. So there's a new Dodge data report, and from that report, it's showing how architects are using BIM now and how they will in the future. So currently, 60% of architects that are using BIM are reporting that over half of their projects are currently on BIM, and with a total of 89% forecast by 2024. So MEP and structural engineers. So 51% report using BIM on over half of their projects, with a total of 80% forecast by 2024. Civil engineers, so 46% report using BIM on over half of their projects, with a total of 72% forecast by 2024. And finally, contractors, 41% report using BIM on over half of their projects, with a total of 69% by 2024. So BIM is gaining traction and it's growing quickly. So next we will continue on and answer. We have two more questions before we move on to the next stage. So again, if you'd like to add in your answer into the comment section, and don't forget to add in your email as well. So what does BIM stand for? Is it A, building in models, B, building information modeling, C, buildings in meta, or D, building info models? So the question again is, what does BIM stand for? A, building in models, B, building information modeling, C, buildings in meta, or D, building info models. That's great. It's good to see everyone's paying attention. So yes, the answer, of course, is B, building information modeling. So the next question, BIM reduces surprises in the building process, which results in reducing what? A, cost, B, height, C, elevation, or D, fire protection? The question again is, BIM reduces surprises in the building process, which results in reducing what? A, cost, B, height, C, elevation, or D, fire protection? Excellent stuff. Yes, perfect. So yeah, of course it is A, cost. Okay, so this part of the presentation, I'm now going to go over the practical side of it. So we've gone through the theory. If you have any questions about that theory, I'll answer them at the end of the webinar. Okay, so I've opened up Revit, which is available on the Autodesk website, and you can get a 30-day free trial. And when we open up the software, we're shown the home page. So on the left, we're able to navigate into our models and families to open new projects or old projects. As well, they just give a thumbnail of the past projects that I've worked on and families. So what I'm going to open up is a project that is given to you when you download the software. It'll be the first project that you'll see when you open it. If you don't have that, you can go to the Autodesk website and just enter into the search bar the sample projects for Revit, and they have around 8 different sample projects, which are aimed at the architects, engineers, structural engineers, that kind of thing. And what I'm going to show you today is the simple or the basic sample project for architects. So I'll go through this with you, and then we will attempt a quick project. So when we open up this project, it's the first thing we are shown is a title sheet, and I'll just give you a quick example of what's possible with Revit itself. So we have a basic rendered image of the project and some internal shots as well. So all of this was created using Revit. And with the rendering process, it does require some PC power. So for a basic computer, you can do simple renders, but for those high quality renders, you do need quite a powerful PC, which is quite standard across the board. So I'm going to open up my the 3D model by going to the quick access panel at the top, and I got my 3D house. And here we have our sample project. So the project itself, as I said before in the theory, everything is created in one single model. So we don't have multiple views for our elevations, our plans, our sections. Everything is created in one model, and we just extract views from that. So I'll go back to the presentation page just for the viewers at home who won't be able to see the interface that clearly. What I've done is I've just made the top bar larger so you can see that yourself. So just running across the top, we have a quick access panel. So all the quick tools that you require, like opening, saving, going back, we can do a quick print. We're able to measure, add dimensions, text, and there's the 3D house, which brings me into my view. And you'll notice if you are a CAD user, an AutoCAD user, you'll see some similarities the way it has been organized. So we have all of these tabs along the top, and in each tab, we have a large ribbon with all of the tools, and they've then been organized into panels. So that again is very similar. If you come from the AutoCAD background, you'll see some similarities in that. So what I'll be doing is I'll be always sticking with the architectural tab. The reason being is when you begin with AutoCAD, with Revit, when you begin with Revit, you should always start with learning the architectural side, because that's how we build our project. And once you've mastered the architecture side, you can then move on to the structure or the electrical or mechanical and plumbing side, but you should always learn the architecture first. So on the interface on the left-hand side, we have 2 dialog boxes. We have our properties and our project browser. So these should always remain on the interface because we use this constantly to extract information from our project and also navigate our project. So when nothing is selected in my model, it just displays the properties of my view. So again, I can go back to my webinar, so I show it enlarged. So we can see here is the quick properties of the view. We can see the scale. We can show the graphics display, all of the types of disciplines that we have, and same with our project browser. This is where we organize all of our different views from the floor plans, ceiling plans, our 3D views, elevations. All of those views are organized into the project browser. So everything that you need is basically in front of you. There's no need to go into any hidden folders or files or extensions to try and find what you want. Everything is there, made simple. It's extremely user-friendly. So to show you some of the benefits now of using the software, So what I'll do is I'll show you some of the basic properties. And if I select the roof, so in the properties side, first thing I have is what's called a type selector. So we have two different types of roofs that we can choose from. And within the library, there'll be more as well. As you progress with your skill level in Revit, you'll also create your own roofs. So the various different properties that we have available to us. The first thing is the constraints. Now, constraints are very important within Revit. So because we're working in a 3D environment, our components have to be constrained to something, otherwise they're just floating in space. So we'll either constrain it to a level, to a wall, or that's what the roof is currently constrained to a wall. So those types of things we have to be mindful of because we're working in a 3D environment. So other quick things that we have available to us under, say, the dimensions heading, we can show the actual thickness of that roof, the total volume, and the area it covers. So we have all of this data available to us very quickly, which in other softwares isn't that readily available. We'd have to go into certain tools to calculate that information, when in Revit, we'll just select it. In the property section, we have all of that information. Same if I select a window. You can see the properties section, just all the headings change, takes on all the properties of my window, and again displays that information. So it's showing what level it's currently constrained to, which is level 2. It's got a sill height of 0, so it's sitting on the floor. It shows the materials and finishes, so what frame it has, the glass, all of that kind of information, all of the dimensions, the identity data, and so on. Same with the wall. Again, all of our different constraints. So it's constrained to level 2, all of the information that we require. And it's very easy and simple for us to either change the information in the property section or in the drawing. So what I'm going to do is come down to the project browser. So the project browser, this is where it'll contain all of our views of our model. So you can see we have our floor plans, our 3D views, elevations, our sections, detail views, our renders, sheets, and everything like this. So this is where it contains all of those views. So within my floor plan, what I'm going to do is open up level 1. And so we have our level 1, and what I'm going to do is open up both views at the same time. And I'm going to demonstrate that we are using one model. So any changes that I make in the model will be reflected in all views. So down in the bottom here, my level 1, I have the curtain wall, which is not very clear. So what I'll do is I'll open up level 2 so it's clearer, so we can see. Yeah, so there's my window. So if I select my window in the 3D model, you'll see on my level 2 floor plan, there is my window. So what I'll do is if I delete it from the floor plan, you'll see it's also deleted from the 3D model. Again, if I select one of the windows, there's my standard type. What I can do is I will change the width. And we'll see the change not only in the 3D side, but also in the plan. So we see the frame got thicker by 200 mil. And in the plan as well, it also got thicker. And you'll notice that all windows have updated together because they're all part of the same family. So going through some of the other views. So in my 3D views in the project browser, we're able to save certain camera views. So this is a great and quick tool to show our client that this is what we've created. And another benefit is we're able to see if there's any errors. So when we're using a 2D software, you can't foresee some design issues because you just don't see that it's in the plan. But when we create it in 3D, you can see that sometimes some walls or a beam might clash with a wall. So it's a huge benefit of having it in 3D. So some other views that we can create. Again, this is all available for free from the Autodesk website. Great. So just a moment while Revit has just frozen a little bit. So has anyone used any other 3D modeling softwares? Has anyone used the AutoCAD architecture software? You can write in the comments. Okay, so Revit's come back. So there we see an internal view of the kitchen. SketchUp 3D Studio Max, yeah, all good programs. So with just what I see in the comments, the SketchUp and 3D Max. So what you're able to do is you can develop your project in Revit and you can export it to both 3D Studio Max and SketchUp. And you can also produce a model in SketchUp and bring it into Revit. So it's all compatible, which is fantastic. So another great option that we have within Revit, so showing the section views, is, like I spoke about in the theory, is the energy analysis. So here's one brief example of the our solar pitch around our building. So we're able to track the sun and see exactly how it rotates around our building. So what this means is we're able to see how the shadows lie within the building, or does a room get sun at a certain time of the year, as well does our building overshadow another building, so we can design that out. So as well, quick option we have available are elevations, which is fantastic. And all of these are automatically generated. We don't have to create the elevation. All we do is we build the model, and all of these views will automatically show our elevations, which is fantastic. Same with our section views. We can just use our section tool, draw a section line through our building, and the section is automatically generated for us, saving us countless hours of drawing a section view. So we're able to do our 1 to 20 details of how our floor and wall joins. Again, once you put in the work to build a model, all of these section views and elevation views, they come with the software. So we don't have to do additional work. We can still do our details, so our smaller 1 to 5 details. And we have a full component library where we can really populate this and add more detail to it. So just shut down some of the views, and I'll show you some of the renderings that we saw from earlier. So this again was rendered over Revit. If you don't have a computer that's capable of rendering, what you can actually do is you can send your model to Autodesk. They render it for you and they email the image back to you. This obviously is a paid for item, but when you sign up to Revit, you're given a certain number of tokens or coins, so you can do a couple, say, free renders, but then obviously after time, once you use those, you'll have to either buy more to continue using them. So another great example is scheduling. So the example in this model isn't that detailed, but it just shows what is possible. So this schedule here was automatically generated. It's only showing the plants that are currently in this project. And this is something that you don't have to manually fill out yourself. When you create the schedule, all you do is you tell it what you want to look for. So this schedule, when it was created, it was told to look for plants, to name them. You also want to know how many there are. So this is great for door details, so door schedules. So you're able to schedule all of your doors in the project. You can say how many door handles, how many screws are within each of those doors. And throughout the project, if you remove a door from the model or add one in, it's automatically added to the schedule. And then lastly, we have our title sheet. So after this, I'm going to show you a quick demonstration of creating a model. So once everything has been created, what you do then is you just drag and drop your views onto your title sheet and send it out for print. Okay, so I'm going to open up a new project. So within Revit, what they have done is they've created various different template files. So when you open up each one of these templates, the interface is slightly different. So with the architecture template, you can see what I have currently open. But if you're focusing mainly on the construction or structural side, it just changes the tabs slightly, and it's aimed more for that specific person. So like I said before, it's always best to begin your Revit career with architectural template, so you understand how to build a model, and then you can move on to the other sides. So we'll just open up a fresh project. So on the blank screen, I'll close this one down. So when we have a fresh project, you'll see we have these 4 bubbles on the screen. So they are our elevation bubbles. So all we have to do is draw our model in the center of those elevation bubbles, and all of those elevations that I've just showed you in the previous project will be displayed. So within the architecture tab, I have my build panel. So this is where I'm going to build my model. Beside that, we have the circulation for stairs and ramps, and so on. So with our build panel, we have our walls, doors, windows, and every other component is added into this. So our main 3 is the wall, door, and window. Then we have our columns, roofs, ceilings, and floors. So first thing, with our build panel and how we create our model, all of the steps are the same. So we want to build a wall, we select the wall tool, and we'll see that the ribbon has changed, but every other tool will be the same. So we have a modify panel of how we can modify what we've just selected. And towards the end, we have our draw panel, so how we want to draw it. If you choose a wall or a window, excuse me, it will be the same modify panel, but then this draw panel will be how you want to place it. Below that is the options bar. So how do we want to draw our wall in our model? And you'll see on the left-hand side, we have our properties and project browser. So within our properties, this is where we'll select the particular type of wall that we want to draw. So what I'm going to do is we'll come down to the options bar. This is our green bar here. And first one, we have height and depth. So when we have our elevations, I'll just open an elevation plan. We have level 0 and level 1. So I'm currently on level 0, which is my ground floor plan essentially, which is this here. So when I'm drawing my wall, I have 2 options. I have height and depth. So the bottom of the wall, or the base of the wall, will be constrained to level 0. If I choose height, the wall will go up. If I choose depth, the wall will go down. So the reason you'd use the depth would be for a basement or foundation. So when I come back to my layer 0, level 0, choose my wall tool, we have height, which is great. So next is, how do we want to constrain that wall? So our base constraint is level 0. And how high do we want that wall to go? We can either choose unconnected and just add in a height to that wall, which is fine. There's no problem with that. But if you don't constrain it to something, for example, like our level 1, which will be our next level up, you lose out on a lot of benefits. So for example, if our level 1 is 3 meters above our ground level, and somewhere along the line of the project, our level has to change up or down by 50 mil. If we change our level, that means we have to go back to all of those walls and bring them up. If we constrain it to level 1, which is our next level up, when we change the level 1 height, everything that's constrained to that will change. So it saves us countless hours going back, ensuring everything is the correct height. So one quick action will change the height. So what I'll do is I'll constrain it to level 1. And next we have our location line. So we have various different options. We have the wall center line, finish face, interior, exterior. So what that is referring to is the blue dashed line. So how do we want to place it? So when it's at the center line, you'll see it's going to the center of the wall. If I change it to finish face exterior, the dashed blue line is now on the external face of the wall. Other options we have are chain. So each wall is a continuous chain. So they're all joined together. We can also add in an offset and a radius. So what I'm going to do is draw on a quick footprint of a building. And I'll show you a good benefit with doing this. So typically in other CAD-based softwares, you need to draw in the exact length of that wall. And afterwards, to change it, you need to pick it up, move it, and not everything is joined to it, so it takes some time. But with Revit, you can either follow along with the blue information on the screen, which is our temporary dimension. So we can either follow along with the length to try and get what we want, or we can just draw in what we think our basic footprint is, not paying attention to any of the dimensions. And we can now use the revise it method, which there is a rumor it's an unconfirmed thing that Revit actually means revise it. So it means that we'll place in our components and then afterwards we revise that information. So this wall here, I want that to be 8,500 mil. So what I need to do is select the upper line, and there's my dimension. So I change 8,500 and I've repositioned that wall. Same with the top. This one here. Let's run around, that's 1,100. Same here, 235. So at all times we have easy maneuverability for all of our different components. This one here is 5390. And that one. So we can either select it, drag it, and release. So it's a quicker way in which we're able to model. So then, now that we've placed our external walls, I come back to my wall command. I'll come into my type selector, hit the drop-down menu, and there you can see all the various different wall types. So they're easily distinguishable by the name. So wall EXT is your external wall. we have FND for foundation, INT for internal, and we have partitions and retention or site walls. So all of these components are available to you when you download the software. But as you progress your career with Revit, you will begin to create your own, because obviously not every wall type that exists in humanity is not in this library. So what I'll do is I'll quickly draw the internal walls for our project. So when we're drawing it in, I have full control over the wall itself. So I hit the spacebar and I can flip it and rotate it around using those temporary dimensions like so. So if I then just run it up, connect it to the next wall, and you'll see as it's an internal wall, it's only connecting to the main wall here. If I was to use an external wall, it'll connect to that differently. So to edit walls quite easily, we have many different commands that we can use. When we select a component, the ribbon will automatically change because it knows that we want to do some kind of modification. So in the modify panel there, we have all different tools that if you go through them, you'll notice a lot of similar tools to other CAD softwares. So I can quite quickly change the shape. So now once I've added in all of my various different walls, we can then start to build up our little components. So our doors, our windows as well. And to do that, it's the same process. So I go to my door tool. Once I select it, you'll see there's my modification panel again. And here in the green are the actions specific to the door. Over in my type selector, I only have two door types loaded in. I have external double and an internal single. So the reason that the library itself isn't included in the software is there's so many components, it'll just bog down and it won't be very usable because it will be very slow. So what they have done is they've created an external link through load family, and that link will open up our library on our computer. So in here, there are hundreds and thousands of different components, and I'm using the UK metric library. The reason being is because I find there's more components in this. You can download that, and you can also download the Indian specific library. So you can have both running side by side, and you just access it through this. So I want to use my doors. So I'll go into my door folder, and there's my external internal door. So I'll go to external, and you can see all the different door types available. If I select one, you see the preview in the right-hand side, all the different types. So I'm going to choose this one here. So when I go to add in my door, I hover over the wall. I'll zoom out slightly. So you can see there's my temporary dimensions. So they're there to help me to place the door. So if I move it into the center, I can feel the door jolt a little bit. That means that it is centered in the wall. So you can see my temporary dimensions 595, 595. So that's centered. If I don't like the door swing, so the way that the door is swinging, I can hit the space bar and it will flip it to the other side. And to place my door, I simply click. And then once it's placed, I still have control of what I want to do. So if I select it, I can change the swing and I can flip it outside as well. And you can see what it has done because this actual door component has additional components built into it. So it has my door jamb, everything is built into that. So it quickens up my detail process at the end of the project. What I can do is I can quickly add in a door internal single and just add it in here and here. So over this whole process, what I can do now is I can open up my 3D view by hitting the house at the top, and we can get a good idea of our project. So what I can do now, I'll leave it in the 3D view. So when you begin with Revit, it's always best to stay modeling in a 2D environment. But as you build on your experience, you can then start to model in 3D. It takes a little bit more time, but my advice is to start in 2D and then transfer into the 3D. So what I'm going to do is I'm going to add in a window. So again, when I select my window tool, in my type selector, I've only got one window type. So go back into my load family and open up my window folder. So there again, I've got all the different window types available to me. So these are just the ones provided by Autodesk. Many manufacturers now produce their own windows in Revit. So if there's a particular window from a manufacturer, what I do is I just send them a little email. I say, do you have this window in particular in a Revit file? And they can send it to me. So it saves me all that time in creating my own. So what I'm going to do is going to add in a nice bay window into the front. Again, I have my temporary dimensions helping me to put that in the correct location. When I have placed my window in, I then select it. If I come back to my type selector, it gives me various different sizes for me to choose from. So I can either select one of the predetermined sizes, which is great, but I can also go to edit type. I can duplicate this, and I'm able to create my own. So there's the width, there's the height. So I can add in my own width and height if I wanted. So around the back, I can add in additional windows. So again, select the window tool, back into the load family. And let's see what we have, / windows, like so, and just place them in. So again, I just click to place using my temporary dimensions and the dashed blue line. So I make sure that everything's lined up correctly and click. So once it's in, if things are not correct, all I do is I select it, come back into my properties. So there's my level, it's constraint level 1. My sill height is 1200, perfect. My other window, it's off. So I'll just select the sill height in the properties, type in 1200, pressing enter. There we go. So everything is correct. So finally, what I'm going to do is just going to place a roof on top of the building. So the roof, I want it to be on level 1, which you see there in the 3D view. So I go to my project browser, double tap level 1. There we go. That's our preview of our house. And now I go to my build panel, selecting roof. And here we have the same. So there's our modify panel again. So some of the components require you to hit this green tick or red X. So that means that you need to tell Revit that you're finished the process by clicking the green tick if you're happy, or red X to cancel everything. So we have a draw box here to show how do you want to draw in the roof. So you could quite simply design your own by using the line command, rectangle, circular, polygon, anything like that. But Revit has provided us with this dynamic smart tool. So this here is called the pick walls. So the pick walls is fantastic. So all I have to do is I just select the wall and the roof automatically generates. It's attached to the wall. So the core structure of the wall attaches to the structure of the roof. So when I do my sections, everything is lined up perfectly. So when I select the wall, all I do is click, move around very quickly, and press escape. So one small tip when you make a roof, first thing to do is just make the boundary. Forget about all the other information for now, because sometimes it doesn't generate correctly. So I'll just green tick to finish, come back into my 3D model, and there's my roof. So you see that it's automatically made the hip and verge. I had to do no work at all. All I had to do was hit the pick walls, and that's as much work as I had to do. So back into level 1, there's my roof. If I select it, when I select it, all of the ribbon changes. So I'm able to see what kind of tools, because Revit knows that I want to edit this. So I go to edit roof print, footprint. And what I want to do is I want to add a overhang. So I want the roof to spill out over the walls so that when the rain comes, it doesn't go through the external walls. It has a nice overhang for the water to run off. So I green tick, come back to the 3D model, and there's my very basic house. But you can see within 20 minutes, we very quickly made a house with windows, doors, and a roof. So what I'll do now is we're finished the presentation side. I'm going to come back and we have a couple more questions on the practical. So again, I'd like you to write your answer in the comments section. So how are the tools in Revit organized? Is it A, in columns, rows, and cells, B, in boxes, C, in folders, files, and documents, or D, in tabs, ribbons, and panels? So please write your answer A, B, C, or D in the comment section, and don't forget to add in your email as well to enter into the competition. So how are the tools in Revit organized? In columns, rows, and cells, B, in boxes, C, in folders, files, and documents, or D, in tabs, ribbons, and panels? Fantastic. It's good to know everybody's listening. So D, in tabs, ribbons, and panels, that's correct. So the next question, and the final question for today: what is the purpose of the project browser in Revit? So what is the purpose of the project browser in Revit? Is it A, to display the current properties, B, to give access to all views, schedules, and sheets, C, allows the user to access past projects, or D, all of the above? The question is, what is the purpose of the project browser in Revit? We have A, to display the current properties, B, to give access to all views, schedules, and sheets, C, allows the user to access past projects, or D, all of the above? Okay, so we have the answer to this is B, to give access to all views, schedules, and sheets. So I can see some confusion in the answer, but that's okay. So the project browser will not display any properties of our drawing. So the answer of all of the above isn't correct. So to give access to all the views, schedules, and sheets is the correct answer. Okay, so at this point, we'll open the floor for any questions that you might have.
Hi, Steve. Thank you for the amazing webinar. I'm sure we all got to learn a lot. So before we actually start taking up our audience questions, I have one quick question for you. So my question is that as somebody who eagerly wants to learn more and grow more in the field of architecture, what is the right path for me or for a learner? If you
Great,
could
yeah,
tell us that.
great question. I guess what I can do is I can tell you the story of how I started my career. So I studied a Bachelor of Science in Architectural Technology in Ireland. So there I gained my knowledge in construction, and I used AutoCAD to create the projects at the beginning of my career. So then when I moved to the UK, I began to start using BIM softwares, and a lot of the new projects were actually required to use BIM. So then once I transferred over to Revit, I saw the huge potential the software had, and I stuck with it. I went to a 2-day crash course to learn the software, and then put in many hours of personal time to perfect my skill. I did so by redrawing old projects as well as buildings I admired. So my new skills in Revit elevated my position with my previous employer, and I began undertaking larger projects. I then began taking on additional freelance work, which led me to starting my own business. I began doing house extensions, minor projects, as well as teaching the software to new students. From there, I started a new business where I now recreate entire cities, seaports, industrial areas, and all in Revit. So I apply the same ideology of BIM, but on a wider spectrum. So basically, we're creating city information model, which is the next level. So, so this means that I create digital twins of existing structures, combining that with IoT sensors to create a smart city style model. Essentially, you can control or model a city from this model. So from any one day using Revit, I can create a small house extension right up to an entire city. So it's pretty incredible. But none of this would have been possible without learning the software and more first. Excuse me. So my advice is to learn the software, practice creating models at home, and learn construction knowledge is key. It's key to understand what you're building, why you're building it, how materials work together. So that's where Internshala comes into play, I guess. So this is where you can learn from me with my course on Autodesk's Revit.
That's right. First of all, Steve, thank you for the answer and for telling us that story. And for all the keen learners here today, Internshala Trainings is offering a very special 10% discount on our Revit training. So you can visit the link in the description, and you can just go check it out. Steve has helped us with that training. So let's go and register right now. And now you all can type in your questions, and Steve, if you could answer a couple of them.
Yeah, no problem. So if you have any questions, please add them into the comment section. So career advice for fresh civil engineer. I guess, you for civil engineering, for sure, you'll need to begin with the architectural side of Revit. Once you then understand the fundamentals of the software, you can then branch into the engineering side of it. But the hardest part is obviously getting your first job. I know it's not easy. It did take me some time, but once you crack that, everything else just falls into place and becomes much easier. And obviously, to continue being successful in your career is to never stop learning. You have to continuously train yourself. Like as I was working, we all only used AutoCAD, and very quickly Revit overtook. And if you didn't learn Revit, you fell behind. So always be looking to progress your skill and to learn what's out there. So keep your eye on the market, what's happening, and keep going.
Okay, I guess that would be all. No more questions there. So thanks again, Steve, and for everybody who participated today. So I would like to announce the name of the winner. The today's lucky winner's name is Divakar Deshpande, and you have won an Amazon voucher worth $250. So you can just type in you can just email us at trainings@internshala.com, and we'll be giving you away your reward. And thanks everyone again for joining. Don't forget to like this video and share it with your friends. Do subscribe to our YouTube channel and press that bell icon to never miss an update regarding an upcoming session. You can also join our Telegram channel to get updates regarding our future events. The link is in the video's description. And we are also planning another IST practical event on 3D printing next Friday. So you can go and register for that as well. Thank you so much, everyone, and thanks to you again. See you
Thank
guys.
you.
Bye.
Bye bye.